A uniform block is standing on the floor of a moving trailer that's moving towards the right at an acceleration of 2 meters per second square. The dimensions of the block are 25 cm by 12 cm and its mass is 0.8 kg. Only three forces act on the block: the normal contact force N on the block by the floor, the frictional force F on the block by the floor, and the weight of the block. The center of mass of the block is indicated by O. Using Newton's first law of motion, explain why the frictional force acts in the direction as indicated in figure 2. According to Newton's first law of motion, the block should continue to move at its current speed relative to the ground. Friction is the force that resists the tendency for relative motion between the two surfaces that are in contact, and its direction is opposite to the direction of this tendency. Since the trailer is accelerating, there is a tendency for the block to slip backward relative to the trailer. Therefore, the direction of frictional force is forward in order to resist the tendency for relative motion. Determine the value of F. Consider the horizontal direction. The resultant force is F and is equal to ma given by Newton's second law, and this is 1.6 Newton. By considering moments about O for each of the forces shown in the figure, explain why the line of action of the normal contact force N cannot pass through the center of mass of the block in order that it does not topple. Let the center of mass O be the pivot. The torque due to W is 0 because it passed through O. The torque due to F is anti-clockwise and non-zero. For the block to be in equilibrium, the torque due to N must be equal opposite to that due to F. Hence, N cannot pass through O in order to be non-zero. In order that the torque be non-zero. Sketch on the figure a labeled arrow to represent the normal contact force N. Pay particular attention to the position of the line of action of this force. For translational equilibrium, N is equal in magnitude and opposite in direction to W. For rotational equilibrium, N is left of O to provide a clockwise torque about O in order to balance the anti-clockwise torque about the same pivot due to F. Determine the horizontal distance x between the line of action of N and the center of mass O. Taking moment about O, sum of clockwise moments equal to sum of anti-clockwise moments. So the clockwise moment is N multiplied by x, this is x, and F multiplied by 12.5 cm, so x is 2.55 cm. If the acceleration is increased gradually, the block will finally topple backwards about the point P. Explain why this happens. As acceleration increases, the net force on the block would increase. This means that the frictional force to keep the block at rest relative to the trailer increases. This in turn increases the anti-clockwise moments about O, resulting in the movement of line of action of N to the left. As the line of action reaches the limit, which is at point P, the block would topple backwards if acceleration continues to increase.